Happy Friday, my friends. We are getting ready for the last one of the week, Space Week. Galaxies in the universe. I'll see you in 5 minutes. Enjoy the pre-show.
9, 8, 7, 6, 5, 4, 3, 2, 1, fire!
Happy Friday, everybody. It is the last day of the week off. The space week, our time exploring the universe gradually, very slowly, and working our way up. On Monday, we talked about the Earth, Moon, and Sun, and it was really fun. On Wednesday, we talked about planets and exoplanets. It seems just like yesterday we were talking about the life and death of stars. Wait a second, it was yesterday. This is great to keep doing this again and again to get some continuation. Hello to our other friends who just popped in. Suha. Who's Suha? Do I know your name? I think I've seen you before, but I can't remember your name. But thank you for saying hello. And Callie, hi. And Kiwi, hi. Hope to see you as well. I'm excited today to talk about galaxies, which are the biggest major structures in the universe. And they're everywhere, yet they're very hard to see. When we look at our night sky, we don't actually see any of them, except for sort of one, which we'll talk about. So we have a whole hour to talk about this stuff. It's Friday, which is really nice. We're looking forward to the weekend together. So let's get to it. Let's get started. As usual, I like to start out with our daytime sky. Oh, Kiwi's here, and Kiwi is talking too. That's great. It's I always find it weird when birds talk, but they're very intelligent and they can do some really amazing things. So I'm excited to see how Kiwi learns to talk over time as well. So let's let the sun go down. This is our sky today, of course. It's a little chilly today in southern Ontario, but not too bad. A little bit cloudy. We're hoping for some sun this weekend so we can get outside and enjoy springtime weather. But we're going to let the sun go all the way down. I see we have 11 friends joining us already, which is really nice. There we go. And so, by the way, this is our sky that we're going to see tonight. We'll be able to see the moon up in the sky all weekend, just after sunset. So this is a good time to check out the moon. I know we're not talking about the moon today, but especially because it's bright and it's just a thin crescent, you'll be able to see it out tonight. But we're here to talk about galaxies. Now, as I mentioned, we can't really see any galaxies in the sky unless we use binoculars or a telescope, or we have to go to some place that's dark. Now, one of the challenges of living in a city or a town that's very bright, that has a lot of bright lights, is that those bright lights, they shine up into the sky, right? If you have if you live in a town or a city with a lot of bright lights, a lot of houses, a lot of businesses and buildings and apartments and all kinds of things, they produce a lot of bright lights, and bright lights don't necessarily shine down. They sometimes shine up into the sky and they block out all the stars. So this is why for people who live in a city, many of us don't get to see a lot of the real night sky that we might be used to for those of us in the country, or maybe if you've seen one of my programs before or learned a little bit about space, the sky looks a little bit different in a city than it does when we talk about it here. And that's something that we call light pollution. So if we get rid of the light pollution, this is what the sky looks like away from the city lights. A lot darker, a lot more stars, a lot more nice things to see, and we can actually see some galaxies as well. Oh, Emily, you live in a court. Nice. Nice. I live in a crescent, personally. So there you go. There's different... Courts are nice because you actually have some kind of closed off. You can go out on the road a little bit. Pretty nice. Now, there is one galaxy that we can see in the sky. And it's very hard to see when the moon is up, so we actually are going to just get rid of the air for a second so we can see it. Oh, do you see that big glowing haze in the sky? That is the Milky Way. And the Milky Way actually is a galaxy, but people didn't know that for a very long time. It was a really long time before people learned that this was a galaxy. It wasn't really until maybe the 1920s, 1930s, about 100 years ago, humanity learned that we are living inside a galaxy. But before that, people called this the Milky Way because it was some big structure. They knew it was made of a lot of stars. And sure enough, if you zoom in on the Milky Way, you can see a lot of different stars, a lot of other structures too, like these. These are nebulas, glowing, places where stars are born. So the galaxy itself, if we actually bring up a list of all these what we call deep sky objects, you're going to see that a lot of them are right along the galaxy. Things like nebulas and star clusters and open star clusters, closed clusters, lots and lots of stars. That's what a galaxy is, right? And it's because we're looking right along the center of our galaxy as well. So lots more stars. Look at them all. See lots and lots of stars, some nebulas as we go along, lots of things. But that's all that people knew. We didn't know it was a galaxy. We just thought it was a bigger clump of stars. And so it wasn't until the 1920s that we really learned what these things were. Now there is one other shape in the sky, or actually a few, but I'm going to go a little bit earlier, I think, so we can see it. Yeah, just a little bit earlier, not too early. Okay, over here. Just down really low in the horizon is another galaxy that we can see in the sky. We actually don't need binoculars or a telescope for this one, but you need dark skies because it's really tough to see. This is called the Andromeda Galaxy. It's a big collection of stars, hundreds of billions of them, and it is incredibly far away. But before the 1920s, we didn't really know what this was. People thought it was a nebula. It was a dusty cloud that was forming stars, just like all the other ones that we see in the sky along the galaxy, or along the Milky Way, like these over here. Now they look very different. This is the Heart and Soul Nebula, by the way. They're very beautiful, but they do look very different than the galaxy that we see all the way down here, Andromeda. But people didn't know that they were different for a very long time. And then something amazing happened in the 1920s. Or it was really a bit before that, maybe 1910. So about 100 years ago. 100 years ago, telescopes got advanced enough that we could start to peer deeper into space. That we could start to look beyond the stars and take a closer look at things like the Andromeda Galaxy. And because we had bigger telescopes, astronomers could start to look deeper into the sky. And they looked at other shapes in the sky with big telescopes. I'm actually going to show you another galaxy that we can see in the sky called Triangulum. It's right there. Also very low in the sky, but this is another galaxy that people could see. They thought it was a big dusty patch, that it was fuzzy, and they thought that it was the same as the Milky Way. But the Milky Way is different. So let's actually go and take a look at what the Milky Way looks like from outside. We're actually going to start with planet Earth. Yeah, 90 years ago. A very long time ago. Although, as much as we think that 90 years is a long time, in terms of humans being alive for hundreds of thousands of years, 90 years is not that long. There we go. So here's our beautiful planet Earth. And we can actually see the Milky Way behind us. Behind the Earth, back there. So let's just kind of look around. There it is, very, very bright. This is what it looks like in outer space. Now, the other interesting thing, about the Milky Way, the reason it has its name, I love to tell this story, is that the Milky Way, we call it that because it looks like milk, right? It looks like a big streak of milk across the sky. And before the 1900s, we literally thought that it was just a big streak of glowing stars that looked like milk. We called it milk. But thousands of years ago, before there were telescopes, before there was really, really good science, people used to look up at this and say, wow, that really does look like milk. Let's call it milk. It's just milk in the sky, right? And they named it after their word for milk. And the ancient Greek word for milk that we still use today is Galaxies. So the word for milk is Galaxies, which sounds like galaxy. So that's why we call them galaxies today, is we still use that old word for milk. So today, galaxies still mean milk, which is kind of cool. Even other ones. Okay, so now we're going to go and venture outside of the Milky Way, our Milky Way galaxy. So here it is here, big, very bright. And in order to do this, we have to break the rules a little bit. We're going to start flying up on the screen, which, there's no real up or down in space, but we're going to go up anyway. We're going to start to putter up higher and higher and higher. And as we go further up, we go faster and faster and faster. And now we start to see stars move. You can tell that some stars are closer to us, some are farther away. and so they move at different speeds. And this is true of space, but it's really hard to get to other stars, right? They're so far away. So we're traveling at an incredible speed right now, faster than anybody has ever traveled before, and we're going up and up and up. Now, as we go higher up, we're actually going to keep speeding up, and we're going to start to see these dark, dusty clumps of gas and dust in the Milky Way moving. They're changing. And if we keep flying, we keep going up, we're starting to get to see less stars, and we're starting to get above that. Oh, Callie, good question. What's inside a galaxy, and what makes a galaxy a galaxy? That's a lot of galaxies. We are inside a galaxy. That's what this is. So here, let's look at this first, and then we'll answer that question a little bit more carefully. So this is the Milky Way. This is what it actually looks like from outside. We live inside this. We live inside it. You and me, we live on a planet Earth, around a star called the Sun. And the Sun is just one of the stars in this galaxy. It's made of over 400 billion stars. That's a 4 with 11 zeros after it. That's a lot of stars. That's a big number. And what we can see, and this kind of answers your question a little bit, Callie, is that as we go a bit further out, if we go down and look at this frisbee of stars from the side, it kind of looks like the Milky Way we see in the sky, right? Because we live inside this clump of stars and gas and dust, to us, we see the bright line of stars going across the sky. Every star that's in our sky is part of the Milky Way. Every one of them. This is a galaxy. All these stars, and we can go and fly back in and see, as we get in closer and closer, we start to see the stars. All of these stars that you're seeing, there they are. All of them are part of our Milky Way. This is what it looks like inside. Every one of these stars has their own planets. All this gas and dust is forming new stars. And our sun is just one of these many stars that is flying around the galaxy. So if we lived on a star that's closer to where we are now, this is what we would see in the sky. If we go down a bit further, we see something different. But all of these stars are places that there are planets and moons and comets and asteroids. One of these stars is our sun. And when we look up in the sky, we see this shape. We see the Milky Way. So as we go further and further out, this is what we see. No matter where we live, or no matter where anything lives in this galaxy, they see this in the sky. This is the Milky Way. And it's just one galaxy. Spelt a little bit different, Emily. Spelt a little bit different. Galaxy. That's how we spell galaxy. Oops, there we go. So, and this is just one of them. And so answering your question, Callie, what makes a galaxy a galaxy? It's really a collection of stuff, right? You see, we can tell that this is a big collection of stars and gas and dust, but outside of it, there's just nothing. It's empty space. There's some dust and a few stars out here, but there's not really very much. And so we see it as one galaxy. But there are others, of course, right? Remember that one Andromeda that we were talking about before? This is Andromeda over there. So we can actually go fly there. And it takes a bit of time. It's quite far away. So as we fly by it, we get closer and closer. So you see that there's this big clump of space. Oh, Emily, you were just fooling around with the other spelling. I do like your spelling better, to be honest. So we get over here, and there's and that's our Andromeda galaxy, which is a different one. It's another clump of stars and gas and dust. And that's what makes this one distinct and different from the one that we live in. But just like we went into the Milky Way, we can go into this one, Andromeda, the one we could see in the sky. And here, let me show you the one where it is. It was down, where was it? Oh no, I've lost it. Okay, well, let's search. Andromeda galaxy. There. So like this right here is the same galaxy as this. We've traveled over there, but now we can go inside. And again, look at all the stars. So just like our galaxy, this other galaxy has just as many stars, gas and dust, and planets and moons and comets and asteroids. But notice that if we fly up above the galaxy, now we start to see less and less and less stars, right? So really, all those stars are collected together. And the real secret, the real thing that makes a galaxy is the fact that all those stars are bound by gravity. It's gravity that holds them all together in a big spiral clump. Okay. Suha says, is there a black hole in the middle of the Milky Way? There actually is. So here, let's go to Sagittarius. A star. Oops, did I miss it? Oh, I did. There we go. So let's go back to our Milky Way. Whoop. Now there's actually a black hole in the center of every galaxy. Almost everyone. There are a few that don't have them, but most galaxies have one really gigantic one in the very center called a supermassive black hole. They weigh, they're so heavy, hugely heavy. This black hole in the center of the Milky Way, it actually weighs 4 million times as much as the sun. And as we go in closer and closer, you can see just how many more stars there are at the center of the galaxy, right? If we brighten it up, you really get a sense of just how many stars there are. Like, check them all out. And all of them have planets and moons and comets and asteroids. So as we go in closer, I know it's hiccuping a little bit because it's a lot to show all these stars, right? There's so many of them. We're getting in closer and closer. And we'll go in and just take a quick look at that black hole because you asked so nicely. Let's go. Oh, did I fly right past it? I did fly right past it. Okay, let's back up a little bit. Whoop. Okay. Okay, so we got to slow down so we get there. Oh, it's over here. Oh, okay. I was totally in the wrong direction. But look at that. As we go in closer and closer, we can see there's actually a bright cluster of stars at the center of the Milky Way. And in the very center of that bright cluster, oh, that's cool looking. In the very center of that bright cluster is the giant black hole. So we're going to go all the way in. And we're going to start to see a lot of stars. A lot of the big bright stars that are held together at the center by that big black hole. It's really the black hole that holds the whole galaxy together. The black hole is the biggest, heaviest thing in the galaxy by far. Callie says, wow, cool. How do they know how much something like a black hole weighs? That is a great question. I love this question. Let me show you. So if we go in a bit closer, these stars actually move, right? They take a long time to really move. But astronomers have been watching these stars around the center of the galaxy move for 30, 40 years. And every year we go back and check and see where they've moved to. Well, if we speed up enough, we can actually see 30 or 40 years of movement. And you see all these stars starting to move. You might notice that they're actually moving around the black hole. And if we bring up the orbits, okay, that doesn't seem to do anything, unfortunately, but we can see that they're all flying around that big bright spot in the middle. That's our black hole. So as we go in closer and closer, you can see that these stars are all moving right around it. Whoop, there it goes. Right? So those, and we can actually see that. Now there's this amazing thing that we can do with the fact that we understand gravity means that we can do a bit of math, and based on how all of these stars are moving around the black hole, we can do the math and figure out how heavy the black hole is. We do this all the time with planets traveling around the sun. We can weigh planets based on how they move around the sun. We can weigh planets around other stars based on how they move around the stars. And we can weigh black holes based on how the stars move around them. We also weigh galaxies based on how they move around other galaxies. So the way things move, we understand how gravity works, and that lets us make predictions. It lets us figure things out. It lets us determine how heavy things are. And so based on that, based on how these stars move, we've figured out that this black hole weighs over 4 million times as much as the sun. And it's so bright because it's actually sucking up a star. So if we dim things down a little bit, we can actually get a closer look at it. We see these big jets shooting away from it. Hey, Jackson. Don't worry, you haven't missed very much. And you know what's good is, again, you can use this link and rewatch anything that you missed in the early part of the program. Okay, so thanks for joining us, though. So look at this. We're just checking out the black hole at the center of the Milky Way galaxy. And so as we go in closer and closer, now we can see what the black hole actually is. It's actually this big dark spot that we call the event horizon. A black hole is a place... why doesn't Earth get spaghettified? Good question, Emily. The answer is that to get spaghettified, you have to go really, 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 really close. Yeah, it is kind of mind-blowing too, Callie, that we can weigh galaxies, right? So why don't we get spaghettified? To get spaghettified means basically when you get close enough to a black hole, there's a difference in gravity. Okay, so the way gravity works is that if you're closer to something, the gravity's stronger. If you're farther away from something, the gravity is weaker. So if this was a black hole, and this is a moon, it's my squishy moon, if you get close enough to the black hole, the gravity on one side of the moon gets pulled a little bit harder than the other side. So the black hole pulls harder on this side than it does on this side because this side is closer and this side is farther. So that difference in gravity, a little bit stronger here, a little bit weaker here, pulls things apart. And if you get close enough to the black hole, it stretches you out. That's right. And you get what's called spaghettified. It's called spaghettification because it makes you stretch out like a piece of spaghetti. All right. But that only happens if you get really close to the black hole. So Emily, Earth, luckily, is very far away from a black hole, so we don't need to worry about that very much. Okay? Yeah, Jackson, I know it's really nice to be able to talk in the chat and actually talk together as we do the lessons, right? That makes it a little bit more fun. So I get not wanting to just watch it recorded, but it is there. Oops, I flew away. Okay. That's okay. Oh, thanks for liking the video too. All right, let's fly back a little bit. Where are we? Where did I end up? Oh, I ended up outside the galaxy. That's fun. Anyway, that's good because that's what we're talking about. So yeah, so that's kind of why the Earth doesn't get spaghettified, Emily, is that you have to be really, really close to it in order for it to happen. Okay. So this is our Milky Way, and we have lots of other galaxies in the sky. And the guy who started to discover all of these galaxies back in the 1920s, who started to look at other galaxies, his name was Edwin Hubble. Now, we've talked about him before in previous lessons, but he actually was the first person to use a really big telescope and look at other galaxies. And one of the things that he came up with was different types of galaxies. And he actually also figured out that galaxies were moving away from us. This is a really interesting thing. So when we look at all of these other dots in the sky, these are other galaxies way out here. There's a lot of them. One of the interesting things about them is that every single one of them is moving away from us. And you can actually measure that. It's the best way to think about it is if you ever have a police car or a fire truck or an ambulance driving past you. When the siren is heading toward you, it has a higher pitch, and when it's moving away, it has a lower pitch. So imagine a siren as something's going past you like this. It goes... So it's like heading toward you, the pitch is higher. When it's heading away from you, the pitch is lower. And that is called the Doppler shift. The Doppler shift. What's happening is these little waves are getting squished together when it's heading toward you, and they're getting stretched apart when it's moving away from you. Now, this same thing happens in space. And this is a good question, Jackson. Are we moving away from them, or are they moving away from us, or both? It's technically both. So but just to go, I'll get to this in a second, but when we go back to the Doppler shift, this actually happens with light as well. So when you look at something in the sky, if it's moving toward us, it actually looks a little bit more blue. And if it's moving away from us, it actually looks a little bit more red. And if it's moving away faster, it looks even redder. And if it's moving toward us even faster, it looks even bluer. And it's really cool that you can do this. And so we can actually measure how blue or how red something looks in the sky and tell if it's moving toward us or moving away from us. And this is what Edwin Hubble did with galaxies. He looked at hundreds of thousands of galaxies in the sky, and what he found was that every single one of them was moving away from us. Every galaxy is moving away from us and away from every other galaxy. And the way that they're doing that is not that they're actually flying away, not that there's something pushing them away, but space itself is stretching like a big bed sheet or a big balloon that you're stretching out further. So if we had two galaxies, over time they're actually moving away from each other because the space between them is stretching. It's getting bigger, which is kind of crazy to think about. But all of this was the first evidence for the Big Bang, which was how the universe was born 13.8 billion years ago. And this is what we'll look at what the Big Bang actually looks like. So here's what the Big Bang may have looked like. A giant explosion, space itself is growing and stretching, and all those galaxies are moving away from each other. There's no center. All the galaxies are just pushing away because the space between them is getting bigger. But sometimes galaxies can smash into each other too. Sometimes they get close enough to one another that gravity does pull them together, right? The only way, I mean, they're all kind of moving apart because space is growing and pushing them apart. But sometimes galaxies are close enough together that gravity overcomes that. So gravity pulls them together. And a good example of this is our Milky Way. Because our Milky Way and that other galaxy, Andromeda, if we look at Andromeda galaxy over here, they're actually moving toward each other. So the Andromeda galaxy is actually blue shifted. It's heading toward us. And what that means is that in about 4 billion years, the Milky Way and Andromeda are going to crash into each other. Oh, good timing, Callie. Callie asked if a star and a planet would crash into each other when a galaxy smashes into each other. Let's take a look. That's a perfect timing. Perfect timing, because we're going to look at that. So, galaxies when they crash together. Here it is. Okay. So like I said, in 4 billion years, the Milky Way and Andromeda are going to crash together. So this is our Milky Way galaxy. It does actually spin. It just takes a really long time. Oh, hey, Jeremy. Nice to see you. And Andromeda way over here. The space between them is still growing, but the gravity is keeping them together and moving them closer and closer together. So they are moving closer together. Now, when galaxies crash into each other, they're mostly made of stars. There's actually a lot of empty space. So when galaxies hit each other, it's not like two bricks hitting one another. It's actually this really weird dance between the stars. Gravity pulls them in and sends them flying and spiraling around, kicks stars out into space, brings them back together. Stars are flying all over the place. Stars can crash into each other, and planets can crash into each other, but it's really hard to do because galaxies are mostly empty space. But you know what really does crash into other stuff, Callie? Is the dust and the gas. Right? So this is what it'll look like when they collide. But if we go back and look at this galaxy, oops, too close. Sorry about that. If we go in and look at this galaxy, you see it's got all those dark lanes of dust. Those dark lanes of dust. The dust can crash into the dust from the other galaxy, and then you end up with really amazing things that look something like this. This is called a starburst. That's two galaxies that are crashing into each other. And the stars aren't hitting each other, but the dust is crashing together. And that creates this massive shock wave that makes a bunch of stars start to form really fast. And they start to glow really bright. That's what you're seeing in the red there, those red bits. That's called a starburst, just like the candy. So that's the answer to your question. If a star and a planet would crash together when a galaxy smashes into each other, stars can crash together. They don't really, though. Planets could crash into each other, but they don't really. Space is so big, and galaxies are mostly empty space. But what does hit other stuff, what does crash, is the dust and the gas, and that makes a lot of stars born really fast, what we call a starburst. Right? Candy's delicious. Emily says, I saw an orange meteor moving toward us, but why was it orange? In order to really see something turn red or blue, the red shift or the blue shift, it's actually not a big color difference. It's not like when you see a car on the highway and it's moving toward you, does it look blue? Not really. When you see a car moving away from you, does it look red? Not really. Red shift and blue shift are very, very tiny, tiny effects. It's only a tiny little bit redder or a tiny little bit bluer. The only way we can measure it is by looking at other galaxies with a telescope very, very closely and really looking really, really close at the light coming from those galaxies. So it's actually really hard to do on something that's moving, that's closer to us. We need those things to be really, really far away. So an orange meteor that's moving toward you isn't really going to look any redder. It's going to look orange mostly because of what it's made of. And when those meteors fly through the atmosphere, through the air, they burn up. They're moving so fast that they start to generate a lot of heat as air moves around them, and then they explode in a big flash of light that looks a little bit orangey. Most meteors do look kind of that orangey yellow color. Okay. So that's very different than the Doppler shift, than the red shift, than the blue shift. Okay, so it's kind of hard to separate those two, and that's a really smart question though, Emily. Thinking about that, but meteors are really, it's just about how they're interacting with the air when they explode. Okay, thanks for that question. And I wanted to show you another galaxy in Sandbox because they look really nice. You're welcome, Emily. No worries. So this is what a galaxy looks like in Universe Sandbox, and again we can see that they're mostly just a bunch of stars and gas and dust, a lot of empty space. And if we let time go forward, you can see how all the stars are moving and interacting. Right? They move all the way around the galaxy at different speeds. Right? Closer stars have less distance to cover, so they tend to move a little bit faster. But again, the stars aren't crashing into each other. Galaxies are mostly empty space. And so when we collide two galaxies together, like if we do the Milky Way and Andromeda colliding, or let's just do a random galaxy collision. Right? So if two galaxies are going to collide, just like we watched, again, gravity takes over. The stars all just kind of pass by each other, right? They kind of fly out and fly away. But it's that dust and the gas that really crashes together and makes new stars. And that's why, when we see galaxy collisions in space, we can actually see a bunch of them. All of these are colliding galaxies. And look at all the different shapes and interactions, and they're twisting and bending and flying all over the place. And it takes a very, very long time. It takes billions of years for that to happen. But we're seeing it in one moment in time. We're just seeing a little snapshot of it. So if we go back to here, and we fly out of the galaxy, this is Andromeda, we have this galaxy, we have the Milky Way moving toward it, and we have all these other galaxies in the universe moving away from each other. All just kind of flying out through space, moving away from one another as space grows. And you can really see how big the distance is between these galaxies, right? They're just kind of little dots separated by huge, huge amounts of dark, empty space. It's pretty big too. Okay, so that was how all these different galaxies moving away from each other. We know that that's how the universe is growing. We've got galaxies colliding with each other only if they're close enough to pull each other in, and then they make bigger galaxies. And actually, this is how we think galaxies in the universe were born. Is that they actually started out as much smaller ones that all collided together to make bigger galaxies. And I thought it'd be fun just to watch, a bunch of them crash together. So small galaxies crash together and form bigger ones. Bigger ones grow by making new stars from the gas and the dust that's in them. And then over time, they get older and older and change. And we end up with lots of different things, lots of different galaxies in space. So this is, I think, where we should talk about the different types. So let's take a look at a few. And again, I've shown these before, but they are quite interesting. So let's start with something. This is a pretty traditional galaxy. It's a spiral galaxy called the Whirlpool. It's pretty beautiful. You can actually see the other galaxy on the far right side is sort of crashing into it. That's a small one called a dwarf galaxy coming in closer. So that's one. There's a bunch more. This one I really like. This is called the Sunflower, because you can see all those dark lanes of dust and all those brand new blue stars. This is a close-up as well, right? Then we have really fun-looking ones like the Sombrero Galaxy. I really like this one too. It's got a whole bunch of stars. That's that glowing kind of light above and below it, and then this dark lanes of dust going across it. And then there's even another type that's very they're called irregular galaxies, like the Cigar. It's called the Cigar Galaxy, but it's actually got some really weird structures. We think that this was part of a collision from a very long time ago. So we see all these different ones, all these different shapes, all these different types of light and different looks to all of these different galaxies. How do we make sense of all of this? Well, that very smart guy named Edwin Hubble, when he found galaxies, when he looked at thousands of them back in the 1920s, he put together a list of which galaxies were which and categorized them all. And he basically came up with two main types: ellipticals and spirals. An elliptical galaxy, which we'll take a look at, is very round, kind of football shaped. So let's go find one. Let's go fly over to an elliptical galaxy. So they're very round, very football shaped. They're made mostly of stars. There's no gas or dust to make new stars. This is literally just a giant football shaped collection of stars called an elliptical galaxy. And if we go inside it, we'll see just how many stars there are. We don't want to go too fast. Dwarfs on dwarf galaxies, yeah. So lots, you can see a few stars kind of flying around, but it's really just a big glowing haze from all those stars shining together. And we can go right on through. We go back. Whoop. It really just looks like a big, bright, hazy, fuzzy spot. It's because it's all older stars, which are more red, and a lot of empty space. Not much gas or dust, and that's just one type of galaxy. And we can see it amongst all these other ones. It's also very big, too. Let's go look at a random one. Let's go look at that dot right there. Let's go see what it looks like. This is called an E5. Okay, so this is an elliptical galaxy. And basically the numbers that Hubble came up with were how football shaped the galaxy is. So this one, basically if you look at this, E0 would be perfectly round like a ball. E7, which is the highest, would be very stretched out. Like almost like a football or rolling out some dough. Something like that. So this one was a 5, which means it's really kind of stretched out a little bit. We can go right inside this one too and see what it looks like. Again, just lots and lots of stars. You see them all? Lots and lots of stars as we fly on through. Pretty cool looking though, huh? So that's another one. Let's go look at another random galaxy. What's this one here? Okay, so this is a spiral galaxy. So let's go fly over to that one. So you're starting to see the patterns, right? There's lots of galaxies kind of spread out throughout space, and they're of these different types. So this is actually called a barred spiral because it's got this really long kind of barred structure in the center. So you can see that long bar that goes along the center. And if we look at our little group, our little classification scheme here, SBA, SBB, SBC, those are barred spirals. They got that bar structure, and they're spread out as you go from A to B to C. So this is an SBC, which is pretty spread out. And again, it's a lot like the Milky Way. It's got those dark dust lanes. It's got lots and lots of stars and gas. It's forming new stars, right? All that dust turns into new stars. Jeremy, very excited by galaxies, I think. Right? And we can fly right on through and go see some other galaxies. Okay, let's go to another one. So this is a good way to explore and see different types. What else do we have here? An S0. This is a perfectly round... Oh, S0. That's an interesting one. Okay. I haven't seen one of these in a long time. This is basically a perfect spiral. A perfectly round spiral galaxy. And you can see the S0 right in the middle. It's literally a round ball with all those spiral arms going right around it. That's pretty beautiful. I like that one. Let's brighten it up a little bit. There we go. So you can see just how different each one of these galaxies are. And you know, they all have lots of stars and planets and moons and comets and asteroids. Lots of different things in this galaxy. And I'm sure I've shown you this picture before, but I'm going to do it again because I do love to show this photo to really understand what the galaxy is. I mean, it helps to go fly into them. But this is a picture of the Andromeda Galaxy that was taken by the Hubble Space Telescope. And you recognize that name, Hubble, right? The same guy, Edwin Hubble, who discovered all those galaxies in the 1920s, they named the Hubble Space Telescope after him because it looked deeper into space than anyone could. And that's kind of what Hubble did. So this picture I love because we can zoom in and actually see all the stars and the gas and the dust in this galaxy. If we zoom right in, you can see those hundreds of billions of stars all kind of flying around each other. And these are red and blue and white and some yellow and orange stars too. We see star clusters, and as we go closer and closer to the center, we see dust lanes, we see all kinds of stuff. This is what our galaxy really is, and this is what every galaxy is. There's just countless stars in each one. So the universe is big. It's got a lot of stuff in it. And it keeps going and going and going. Let's go and look at a couple more. A couple more galaxies. Let's see what else we can find. E4. I really want to find just a standard spiral. Oh, here's a good one. Haha. An irregular galaxy. Now, there are some galaxies that don't really fit into the types that we have at all. We look at this, we have ellipticals, we have spirals. There's some galaxies that look very different than all of those, and this one I like a lot. Look at this, that's beautiful. This is called an irregular galaxy. It's not a spiral, it's not an elliptical, but it is a big clump made of lots and lots of stars. This one actually doesn't have very many stars either. Let's see some info on this thing. It's only got 8 million stars, which does sound like a lot, but this is really a small one. Look at all that gas and dust. Isn't that beautiful? It's like a giant nebula almost. But we still call it a galaxy. Okay? So irregular ones are basically ones that don't fit into the ellipticals or the spirals. The vast majority of galaxies are ellipticals or spirals, but some of them are... I'm actually going to take a picture of this one because this is really beautiful. Let's take a little screenshot. There we go. Always nice. Okay, let's look at some others. Just a couple more. Oh, there's another irregular. So let's see how this one is different. This next irregular galaxy. I tell you, I have so much fun just kind of puttering around in space through this program. Look at this one. See, that's kind of cool looking too, right? Dark dust lanes, lots of stars. Again, irregular. Not a spiral, not an elliptical. Very, very different. Okay, let's try and find a normal spiral galaxy to look at. That's irregular. S0, not quite, not what I'm looking for. SBA, that's a barred spiral. Another irregular, holy smokes. E6, E2, irregular. Holy moly, we're finding a lot of it. Okay, there we go, SB. So SB is a standard spiral galaxy, no bar in the center, no bar structure, and just these spiral arms. So let's come back to it. And there it is. There's your standard spiral galaxy. Just a lot, sort of like the Milky Way. The Milky Way actually does have a bar structure, but that's pretty cool. So these really are, galaxies really are like islands in the vast ocean of the cosmos, in the ocean of the universe, right? There's a lot of empty space in between them. But galaxies, as you can kind of see, if we fly through, you might notice that there's some clumps to the galaxies, right? There's clusters of them. And galaxies do actually cluster together. So let's see. If we look at this. Whoops, wrong picture. Nope, wrong one. We've actually mapped a bunch of galaxies into two types of things, clusters and voids. So there are places where galaxies collect together, We call those clusters and superclusters, and there are places where there are no galaxies. There's just big empty spaces. We call those voids. These are the biggest structures of the universe. This is what the universe looks like on the biggest scale, is when you fly through it, you can see these big structures. You can see clusters. Whoops, sorry for going too fast there. You can see big clusters and voids. And if we actually dim things down, it makes it a little bit easier to see the clusters and the voids, I think. That's probably too dark. Let's just brighten it up and see how that looks. That might help. Yeah, so you see lots of galaxies, but you can tell that they kind of stick together a little bit, and then there's big empty spaces too. This is the big universe. This is what the universe really is made of. Pretty cool. Okay, so some other things to talk about with galaxies. We have some large ones and some small ones. The largest galaxy that I really wanted to show you is this one. This is called IC 1101. It is the biggest, it's an elliptical galaxy, and these are often found at the center of galaxy clusters, the center of those big clusters. Because what tends to happen inside the clusters is a bunch of galaxies crash into each other and get bigger and bigger and bigger. And you can see the Milky Way in the very bottom left-hand corner, that tiny little dot. You can see Andromeda, another small dot. You can see M87, which is a surprisingly big elliptical galaxy. And here is IC 1101. So let's actually go to M87. And then we'll go over to the really big one, IC 1101. Oh, Emily, you're keeping me in suspense. You say, let's see So there's a pretty big, a void. Okay, let's see a void. Now it's kind of hard to see a void, right? Because voids are empty. They're places where there are no stars, no galaxies. So there's a big one there. Quite a few stars in this one too. Kind of cool, eh? Imagine living around one of these stars, and you look up in the sky, and this is what you see everywhere. It's just like this haze, this glow. There's another one over there. Let's fly out to that one. You can see other galaxies too. So let's go to, let's try and find a void. Like it's hard. In this program, I don't know if they have the Boutez void. No, we don't. So it's really hard to kind of see a void in space because it's really where there are no galaxies, right? So I guess actually, you know what? What's the best way to show this? Here, let's fly back a little bit. Okay. So this is kind of a loose cluster, but let's think about this for a second. I think the best way to do this would be to look for a cluster and then go kind of next to a cluster. It's really hard to not see anything, right? Because there's just galaxies everywhere. One thing that is kind of neat is that if we actually look here, we can turn off this setting called intergalactic vision. And now we see nothing. And you're probably thinking, what's going on? Why aren't we seeing anything? Well, the reason is that galaxies are so far apart, and even though they're made of a lot of stars, if we were out in outer space, in the universe, and we're at a galaxy, we can see that galaxy, but we actually can't see anything else. There's another one over there. There's a couple more. But really, we can't see very much in space because space is so dark. Human eyes just can't see very much. Okay, so we see this, and we know there's lots of galaxies out there. I mean, this is why it took so long for human beings to discover other galaxies, is because when we looked up in the night sky, we can only see one or two of them. If we look past the stars, you know, we zoom in, and zoom in, there's stars, but we don't see anything else. We just see empty space if we zoom in far enough. There are galaxies there. And if we zoom into that empty space, the galaxies, if we go all the way in, it would actually look, if we could see them, it would look like this, right? All of these are galaxies. And they're everywhere. They're all over the sky. We just don't have eyes that are powerful enough to see them. And even when we do use telescopes to try and see them, we have to take pictures with those telescopes for hours and hours and hours in order to actually spot them. Okay, so it's really, really tough. And it's also really hard to understand because there's so many galaxies out there. They're so far away. They're everywhere, but human eyes can't see them. And that's why it took until the 1920s for us to really understand what they were, what they looked like, where they were, and really what they were made of, and what types they were. That's why it took so long to get this, right? That's why it took so long to see other galaxies in space. Today, you know, we're lucky because we know that there's so much more stuff out there. We know that when we go back to Space Engineer, we can turn on that setting for intergalactic vision and actually see all the galaxies that are actually out there, right? Because there's a lot of them. So we're really lucky to have an understanding of what our universe really is. This I think is a galaxy cluster. This is I think this is called the Virgo cluster. So you can kind of see all these galaxies kind of stuck together, right? Like you see how many more of them are just kind of floating around in space here. Well, if we go just outside that, look, there's your big void. I know it doesn't look like it, but there's no galaxies nearby right now. You see as we move, you can kind of get a sense of the 3D structure. There's just nothing here. But when we go back over here, there's that big wall of galaxies crashing together. Yeah. So this is actually called the Virgo cluster. M87 is in the center of the cluster. So, and Virgo cluster is the closest one to us. We can actually see it. We see some of the galaxies in it in the sky. Actually, I think if we look up, there's this thing called Marciniak's chain. Marciniak's chain. And I'm going to show you pictures of it. Yes, that's what we're looking at. I'm just going to pull up a photo here. Oh, that's a terrible picture. Can we get something bigger, please? Yeah, this is... Okay, this is better. Open image. There we go. Let me show you. This is called Marciniak's chain. It's actually a bunch of galaxies that are all very, very close together. And I think this is M87. I think that's that big one. This is all part of the Virgo cluster. And you're seeing some stars in this picture, but most of these things are galaxies. And so this is kind of what we're seeing here. This is that big kind of clump, the galaxy cluster. Oh, there's a big one back here. Let's go see what's way back here. Right, so here's a big clump of galaxies. You can really tell that they're all kind of hanging out together. When we get closer, you know, they spread out a little bit more, but this is a big... What is this? NGC. Okay, so yeah, this is probably a cluster. Oops. So, kind of neat. We can fly around that a little bit and see that there is a big cluster here. Some of these galaxies might even be colliding too. But when you get closer, you see how far apart they really are, right? So they're... So this is why it's really tough to understand and see, you know, voids and see clusters in space, even in this program in Space Engine, right? Okay, so we're about 5 minutes to the top of the hour. I'm trying to think of what else I wanted to show you. So let me just look at my notes here. History in the sky, Hubble, deeper universe. Okay, we talked about all that. All right, with our last 5 minutes, what else would you like to talk about? We can go and explore a few other galaxies, such as the ones in Marciniak's chain or anywhere else. We can go see some others. We can go and explore some things inside other galaxies. We can see some more collisions. You tell me what you're interested in, and we'll go and take a look. In the meantime, I'm going to pick some random galaxies and go look at them so we can see some others. So let's go over here. We have an E7 elliptical. E7 is the most stretched out one too. So if we go in, we can take a much closer look and see. There you go. So that's like just shaped like a line. It's very, very wide, right? That's your E7, the ones that are really, really stretched out. Jackson says the really big galaxy, IC 1101. Yes, IC 1101, the biggest galaxy in the known universe. All the way over there. M83. Okay. We'll go see M83 after. Yeah, that's right. Yeah, that's the one, Jackson. IC 1101. This is the biggest galaxy in the universe. And it doesn't really look it, but if we actually... here, we'll brighten it up just a little bit. You too, Jeremy? You're good with the biggest one? So if we zoom away, if we fly away a little bit, you can see all those other galaxies around it are much smaller, right? Like you see these, like that, this one up here. Like here, this will look really cool. So here's an irregular galaxy, right? If we go there, you can see as we get closer. Why is everything disappearing? Oh, I know why. Okay. So like, you know, here's your irregular galaxy, and there's IC 1101 in the background, the giant one, like super bright and super big. So like, you know, there's a galaxy nearby. That one's a lot bigger. And actually, with IC 1101, if we get some info on it, it has 150 trillion stars. That's like over a let's see, 110, 20, 100. That's 400 times as many stars as the Milky Way. That's a lot. Gracie asks, can we go back to Earth at the end? Of course we can. We'll take the nice long flight all the way back to Earth. I'm going to look at M83 for Emily, and then we'll go do that. M83. So what's the deal with M83? It's a galaxy. It is an SC spiral, so let's go fly over to it. Flying through space. Yeah, you can see clusters now, right? Okay, so this is M83. Interesting. Very nice looking galaxy, right? Looks kind of spinning and spirally, and it's got some really interesting spiral shapes. It looks like it's forming lots of stars. You can see some of the red glows further out here. If we go kind of in a little bit, you can see all these nebulas forming new stars. Kind of cool. It's got a really neat shape. Lots of dark dust. What's the deal with M83? Like, I'm kind of curious about it too. Ooh. All right, let's bring up some info on it. So it's got 22 billion stars, so it's quite a bit bigger than the Milky Way. About 5. Oh yeah, there you go, Jackson. How many stars? So 22 billion stars, which puts it, you know, the Milky Way's got 400 billion. So this is 50 times bigger than the Milky Way. That's huge. That is a really big spiral galaxy. And yet it's actually not that wide. So it's very narrow. It's not very wide, but it has a lot more stars. So it's very dense. It's got looks like it's got a lot of gas and dust. It's forming it. Whoa, that's bright. Let's dim that down. It's got a huge, huge number of stars for a galaxy, for a spiral galaxy. Pretty cool. Pretty neat. Yes, blinding everybody again and again and again. Always fun. That's pretty cool. Okay, so let's go back to the Earth. Now I'm gonna take. We're pretty far from Earth. We're 15 million light years from Earth, so we've got a bit of a trip ahead of us, right? So let's go. We won't go too slow or too fast. We'll just get there. We'll take a nice leisurely trip back for Gracie, so that we can get all the way back to our home. So it'd be kind of hard to find the Milky Way amongst all these other galaxies, right? Like, we're so far away. It's kind of hard, but here it is. As we go back in, we're going to slow down because we want to make sure we actually get to the right spot to find the sun and find the Earth. So here we go. We go back into the Milky Way. We start to see all the stars that make up our galaxy. As we go closer and closer, we're still slowing down pretty quickly so that we can go closer and closer. We're going to start to see some of the stars that make up the constellations. You can still see the Andromeda Galaxy here in our sky. And we go closer. We're only about 200 light years away now. Whoa, let's slow down so we don't go too fast. We're going to start to see the sun in the middle. The stars are going to start to slow down. There's the sun in the very center. We got to slow down quite a bit more. All right, here we go. 10 seconds from Earth. I was hoping this would be a little bit slower, but we just flew by the sun, and here we are. So that's it. Like, this is where we are. This is where we live. We're in, you know, there's irregular galaxies. There's the Large Magellanic Cloud. It's an irregular galaxy that orbits the Milky Way. It's right there. there's the Earth. This is our home. And I think that's a good place to finish. So today, my friends, we talked about galaxies. We actually got to explore a lot of galaxies. We talked about how we knew what galaxies were that we didn't know until like the 1930s, that we didn't know what the Milky Way itself was, even though we could see this big streak in the sky, that we discovered Andromeda, the closest one to us, and we used to think it was a nebula. We learned that 100 years ago, Edwin Hubble looked up into space and discovered all those galaxies and realized that they were all moving away from us and from each other, which told us that the universe was expanding. We learned the different types of galaxies, the spirals and the bar spirals and the ellipticals, kind of football shaped, some stretched out, some round. And then we looked at irregular galaxies, which were really beautiful, a lot smaller, a lot different. And then we looked at galaxy clusters and voids and the biggest structures in the universe. And so that, my friends, will actually conclude our Space Week. We've had 4 really fun programs. I want to thank you all for joining me for these. We've got a lot more things coming up. We're starting our Wednesday streams again, starting next week. We're starting Saturdays again, Space Saturdays next week. So I hope to get to see you again for all of those. Next week, I think we've got, Constellation Stories is next week. And our Spring Sky, I think, is coming up. So we've got a lot of things to talk about in the next few weeks. So thanks for joining me for your week off. I really appreciate it. And I hope to see you again for a lot of more fun. See, right at the very end, I forget how to talk. Looking forward to a lot more fun programs and to seeing all of you again soon. Thanks for watching. This is Ryan signing off for Space Week. Have a great day.